Alright, so here we are, section 1.5. We get midpoints of segment. It's going to be a point that divides or bisects a segment into two congruent segments. So whatever point in the segment, if you folded that segment on that point, both sides would be exactly the same length. A segment bisector is going to be a segment, ray, line, or plane that intersects a segment at its midpoint. So any of these figures, if they go through the midpoint of a segment, another segment, array, a line, plane, anything that goes through the midpoint is going to be considered a segment bisector. So here we have this diagram. Point M is the midpoint of segment AB. And so M is on segment AB, and the length of AM is equal to the length of MB. Likewise over here, if point M is our midpoint and I have line CD going through that midpoint for segment AB, then line CD would be considered a bisector of segment AB. And once we get into using our compass and straight edge, we won't do that till later on in the year, but it's possible to take a compass and straight edge and just construct a segment bisector and midpoint of segment AB. And when we are using a compass and a straight edge, that's called a construction, which is a geometric drawing that uses a limited set of tools, usually a compass and a straight edge. So using those two tools to create some sort of geometric drawing is considered a construction. All right. Now, midpoint formula is something you might be familiar with from algebra. And midpoint formula says if A, which is point x1, y1, and B is the point x2, y2, are points in a coordinate plane, then the midpoint of segment AB has the coordinates x1 plus x2 divided by 2, y1 plus y2 divided by 2. So we take the x's from the 2 points, add them together, divide by 2. That gives us the new x coordinate. Take the y coordinates, add them together, and divide by 2, and that gives us the y coordinate for the midpoint. So using that formula, the midpoint of segment DE with endpoints of D, which is 3, 5, and E, which is negative 4, 0. So using that midpoint formula, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So D, we're going to call that x1, y1, E, x2, y2. So our midpoint is going to be the x1 plus x2, which is 3 plus negative 4 over 2. And then the y1 plus the y2, which is going to be 5 plus 0 over 2. Simplify those down. 3 plus negative 4 will be negative 1 over 2, or negative 1/2. And 5 plus 0 is just 5. Over 2 is 5/2. So the midpoint of segment DE would be negative 1/2, 5/2. All right, this is a little more complicated option. It says the midpoint of segment XY is 3, negative 4. One endpoint is point Y, which is negative 3, negative 1. Find the coordinates of the other endpoint, or the point X. So let's say we have a segment here, segment XY. And we got the midpoint M, which they gave us the coordinates of that, which is 3, negative 4. And they gave us the coordinates of point Y, which is -3, -1. So we need to take those two coordinates and come up with the coordinates of x. So we know that the midpoint, x1 plus x2 over 2, and y1 plus y2 over 2. And so this is how we get the midpoint, but they gave us the midpoint already. Which is that's x1 and y1 for the y points. Then the midpoint is -3 plus x2 over 2, and y1 is -1 plus y sub 2 over 2. So this is part of the midpoint. We're trying to figure out what x2 and y2 are, but we do know what the midpoint is. Right? So the midpoint is the point 3, -4. So -3 plus x sub 2 over 2 has to equal 3. And -1 plus y sub 2 over 2 has to equal the -4 from the midpoint. So now I can set those up as two separate equations. So -3 plus x sub 2 over 2 is going to equal 3. That's for the x equation. And the y equation, -1 plus y sub 2 over 2 is going to equal -4. We work to solve both of those. So multiply by 2 on both sides to get the 2 out of the denominator. -3 plus x sub 2 is going to equal 6. And then add 3. It's going to give us 9. So the same process over here for the y. Multiply by 2. Those will cancel. So -1 plus y sub 2 is going to equal -8. Add 1 to both sides, and y sub 2 is going to equal -7. So the coordinates of point x is going to be 9 for the x and -7 for the y. Alright, so angle bisector, kind of like segment bisector, except for it's in an angle. Alright, so a ray that divides an angle into two adjacent angles that are congruent. So adjacent angles are side by side. So a ray is going to split one angle into two angles that are side by side, and they're congruent. They're the same measure. So we have angle ACB, and if ray CD is a bisector of that angle, then that creates two congruent angles, angle ACD and angle DCB. So those two angles are congruent. And notice these little red arcs here, that's the way that we would mark to say that two angles are congruent. They're going to both have one arc here. So since they both have one arc, that's saying that this angle here is congruent to this angle here. Alright, so ray JK bisects angle HJL. So angle HJL, JK is a bisector. So that means those two angles are congruent. Given that the measure of angle HJL equals 42 degrees, what are the measures of angle HJK and angle KJL? So, measure of angle HJK is going to be half of the measure of angle HJL, and also the measure of angle KJL is going to equal half the measure of HJL. So, measure of angle HJK is half of 42, or the measure of angle HJK is going to be 21 degrees. And since KJL is also half of HJL, measure of angle KJL is equal to 21 degrees as well. All right. So if we add those two together, they should equal the full measure of angle HJL, which is 42 degrees. All right, a cellular phone tower bisects an angle formed by two wires that support it. Find the measure of the angle formed by the two wires. So we have this cellular phone tower. We got a wire that goes on each side of it to hold it up. And on one side, we see that the angle is 47 degrees. We want to find the measure of the entire angle, which if it bisects that angle, if that tower is bisecting the angle, then that means that the other angle also has to be 47 degrees. So the measure of the angle is going to equal 47 plus 47. If we add those two angles together, measure that angle is going to be 94 degrees. All right, in the diagram, ray MO bisects angle LMN. So we have angle LMN here. Ray MO is a bisector. And the measures of the two congruent angles are 3x minus 20 and x plus 10. So this angle is given to us as 3x minus 20. The other angle over here given to us as x plus 10. But we know that those are congruent angles. That angle is congruent to that angle. Or in order to solve for the x here, since the two angles are congruent, their measures should be equal to each other. 3x minus 20 should equal x plus 10. And then it's just solving for x from here. So subtract the x. 2x minus 20 equals 10. Add 20 to both sides. Give us 2x equals 30. And divide by 2. X is going to equal 15. So our x value for each of these angles is 15. If I add 15 plus 10 here, that would give us 25 for x plus 10. Or 15 times 3 would be 45 minus 20, which would also be 25. So that completes the notes for section 1.3.